in this question, we are given the modulus of a certain vector as 2, and we are told that that vector is parallel to the vector 3, -4. What is the vector? We are asked to find that vector. Let's look at the solution. Now, we are looking for a vector that we don't yet know. So, we can call the vector v, okay? We can call the vector, say, v. With components x and y. The I component is x and the j component is y. So we are looking for the vector v. Now we have two vital information about the vector v. We are told that the modulus of v, the modulus or the magnitude of v is 2. All right, let's explore this information. Now the modulus of v is simply the root of the I component squared plus the j component squared. We are told that that result is 2. If we remove the radical sign by squaring both sides, if we square this side and square this side, remember whatever you do to one side, you must do to the other side in order to respect equality. So we square here, we square here. This square will cancel the square root. We have x squared plus y squared is equal to 2 squared is 4. All right, we can call this one equation 1. So our first information has given us this equation. Let's explore the second information. We are told that the same vector v is parallel to this other vector 3, -4. Remember, one of the ways of representing vectors is by using matrices. So this vector can also be written using the I and j component as 3i minus 4j. You should remember that. Now we are told that v is parallel to the vector 3, -4. It simply means that v can be expressed as a scalar multiple of that vector. All right? K is a real constant. V can be expressed as a scalar multiple of that vector. Now, let's write this out. V is x, I, y, j is equal to k into, let's use this form, the I and j components, 3i -4j. So, xi plus yj is equal to 3ki when we multiply this with k, minus 4kj when we also multiply this with k. So now, we have this vector equals this vector. The condition for the equality of two vectors, we equate corresponding components. That's the condition for the equality of two vectors, because on the left-hand side is a vector, on the right-hand side is a vector, and we're told that they are equal. This is the equality sign. All right, so if we do that, then we are therefore saying that x is therefore equal to 3k. All right, when we equate the I components. And when we equate the j components, we are going to say y is equal to -4k. That is the j component. All right, now we have equation 1, and we can call this one equation 2, call this one equation 3. Okay, remember we are looking for x and y in order to get the vector v. Our question is asking us to look for the vector v. So we need to get the value of x, we need to get the value of y. Now, these are the expressions in terms of k for x and y. Let's just carry these expressions now for x and y and put in equation 1. So we'll putting 2 and 3 in equation 1. All right, so it means wherever we find x, we're going to write 3k. Wherever we find y, we're going to write -4k. That is equation 1. Equation 1 is x squared plus y squared equals 4. So in the place of x, we're going to put 3k. In the place of y, we're going to put negative 4k. All of that is equal to 4. Okay. Now, 3k squared gives us 9k squared. Negative 4k squared gives us 16k squared. Is equal to 4. This is the equation that we are solving. Now, k squared is common in the left-hand side, so we'll factorize out k squared into 9 plus 16 is equal to 4. So 9 plus 16 is 25. So we have 25k squared is equal to 4. If we divide both sides by 25, we're going to have k squared is equal to 4 all over 25. To get k, we need to take the square root of both sides. So we take the square root of both sides. It will give us k is equal to the square root of 4 is 2. The square root of 5, square root of 25 is 5. So this is the value of k. This is the value of k. With this value of k now, we can now see that we will now just be able to get our value of x and y. When we put them, when we substitute in equation 2 and 3. When we substitute in equation 2 and 3, we'll be able to get our values of x and y. Now, let's do that. K is 2/5. Now, x therefore becomes 3 into 2/5, which is 6 all over 5. Pay attention. Here, the 3 multiplies to the numerator. It does not come and multiply also to the denominator. There's a video that I already did earlier on that explains that. This is a fraction. We can make this one also a fraction so that we see numerator go with numerator, denominator go with denominator. And then now y is negative 4 into 2/5. That should give us negative 8 all over 5. Therefore, the vector we're looking for, v, the vector we're looking for is the vector 6 all over 5i minus 8 all over 5j. This is a vector whose modulus is 2 and which is parallel to the vector 3i minus 4j. If we want to check, so what's good to check? If we want to check, we can always check to be sure that it is true. Okay. Let us check the modulus of v to see if it is 2. Modulus of v, remember, it is the root of the I component square plus the j component square. Let's check this out. Do we have 2? 6 squared is 36. 5 squared is 25. Negative 8 squared is 64. 5 squared is 25. So we end up with the square root of the LCM is the same, 25. So 36 plus 64, that gives us 100. So we end up having the square root of 100, 10. The square root of 25, 5. And 10 divided by 5 is 2. So we see that the magnitude of the vector is actually 2. All right. So that's the first checking that we've done. All right. Now, let us check the other part to see if this same vector is parallel to the vector 3i minus 4j. Okay. For this vector to be parallel to that vector, it simply means that the vector v must be a constant into the vector that we have there. All right, let us see if this vector v is actually going to be a constant times this. The vector v, this is it here. So we have 6 all over 5I minus 8 all over 5j. Let us see if we can come out with something multiplied to this vector. Already we have 2 is common here. 2 is common at the numerators. 5 is at the denominator. 5 is at the denominator. So we can have 2 to 5th into. All right. When we remove 2 feet from here, we're going to have 3i. When we remove 2 feet from there, we're going to have negative 4j. So we see that our scalar, just like we calculated, was 2 feet. All right. So the vector v is actually a scalar, a real constant, times the vector 3 negative 4 or 3i minus 4j. Therefore, our solution is correct.